If this is Java, you don't even do this at all. There is a workaround, which is to use fully qualified name. So instead of asking the compiler to understand what you mean by mname, which it doesn't, you basically tell it exactly what you mean by mname when you refer to it in the tutor class. So in tutor class, you cannot refer to any of these only using this name. You have to give it a fully qualified name with scope. And I have an example here. Alright, so here, this is not that example. Sorry, this is not the example. Yes, we can still talk about this in here. So this is the kind of a problem that arises when you have multiple inheritance and there is no clear precedence. You have instead of having tutor inheriting staff and students, which are two separate classes, you have all of these two classes inherit from person, and then having tutor inherit from these two classes. And even though the name variable only exists in person class, right, you would think that this one will refer to this variable. This one also refers to this variable, so there is no ambiguity when you inherit tutor. It should inherit this variable, but that's not what happens. What happens in the compiler is when you inherit employee, so each class in memory will be given a lookup table. When you inherit employee, so when you inherit person will have a variable name mname, or actually just name, in the lookup table. Right, that's fine. Now when you inherit employee from person, what happens is this one gets copied. So the actual variable name here is person scope name. When you inherit this, it gets copied. So you end up with employee scope name and also person scope name. So when you are inside the employee class and you refer to name, the compiler sort of understands that you actually refer to this variable, so there's no problem. Now when you have another class, students, it ends up with the same copying behavior. It inherits person name, and then this variable gets copied into the scope of student. Right. So even though you might think that we declare this variable only once, so we should end up with only one copy of the variable. That's not what happens. What happens is you end up with 5. Actually, I'm sorry, 3. 1, 2, 3. Yeah. So when you inherit tutor from both classes, and you refer to the name variable, the compiler doesn't know whether you refer to this or to this. If you use the full name, full qualified name, no problem. But if you use only the short name, you have a problem. So the problem with multiple inheritance is not only when you declare two variables with the same name in two base classes. It's also when you inherit two base classes from a grandparent class, if you will. Right, so to demonstrate the problem, in the constructor for tutor, I'm going to try to refer to name. And then we'll try to compile. Now, if I compile, I think there will be no problem. days. So even at compilation time, there is a problem. Right? So it complains that name found in multiple base classes. So it found in employee and it found in student. It doesn't know which one you refer to. If you do this, employee, if you refer to it with the fully qualified name, there's no problem. And this is kind of what happens in Python. That when you declare multiple inheritance, the first one will be considered sort of the most prioritized. And when you refer to name only, then it will sort of implicitly use the first base class, and it will insert this scope for you. So in C++, you have to do it yourself. But the better way to avoid this problem, this is kind of ugly, no one wants to write this in the code, is that you declare this relationship virtual. So this is exactly the same as when you declare a function virtual. When you declare a function virtual, you say to the compiler, when you encounter this name, don't try to be too quick. Look further until you find no more. So when you declare employee a virtual inherited class from person, it will not sort of copy this. This will not happen. So when you inherit tutor, the copying actually happens at sort of runtime when you declare it virtual. When you declare something virtual, the behavior, the lookup behavior of the compiler of the machine happens at runtime instead of compiler time. So at runtime, when you call tutor.name, it will copy the name from here to here to tutor. So instead of copying from here to here and then from here to here, and then it doesn't know which one to copy to here, it will copy directly from here to here if you declare this relationship virtual. Alright, so let's try to run the same code again. This time there shouldn't be any problem. Yeah, so this is a bit overwhelming. If you have any question, ask. I guess the key for you to remember all of this is when you see the keyword virtual, this is a signal to the compiler to say any lookup for this name should happen at runtime instead of compiler time, compilation time. Same thing happens to a method. Right, so here we have a data member, and if we don't declare this virtual, then it doesn't know which one to call. The same thing happens when we have a function. So we have a virtual void full. And then you inherit it from here. It's not called full. Full you see out person.